Hi friends, welcome to CAT channel, Civil Architecture Tutorials channel. Today we discuss regarding the points which a civil site engineer had to check before concreting a slab or beam. So we will discuss some of the points which the civil engineer must know, and he should check all these points before concreting, or it will affect the strength of the slab, and eventually honeycombing, or there will be weakness in some parts of the slab can happen. So let us discuss the points one by one. First, you know, in some of the sites I have seen, they have put sleeves in columns or conduits in columns and beams. Means the electric line will pass through some columns or beams, which we will never allow, because it will affect the wall strength of column or beam. Because as you know, beam is composed of two things, that is, one is concrete and another is steel bar. Steel bar function is taking the tension, and the concrete function is taking the compression. So these two forces are acting on the column or beam. So if you put a hollow structure for the sleeves to pass through, then it will affect the wall strength of the column or beam, which is designed to take all the tension as well as concrete. So we will never allow any sleeve or any conduit to pass through columns or beams. Of course, we have seen such things, but it should not be allowed in any construction area. So that is one point. Let us see. Check no conduits or sleeves pass through columns or beams. That is the first point. Second point is shuttering gap should be completely avoided. That is, while doing the shuttering, um, we know that there will be gaps in between the sheets, the metal sheets. That should be avoided. It should be tightened in such a way that there should not be any gap in between. How do you understand there is a gap in between? When you look from above, you may not see it, but for that you have to go down below. From below you have to see whether the light is passing through or not. Of course, you will find some area where the light will pass through. So in such area, the slurry of the concrete will pass through, and eventually the concrete may lose. The concrete will get lost from that particular area, and that area will be weakened. And when the concrete is not there, you know, the compression part is will get weakened. The slab cannot take the wall compression, and there is high chance for honeycombing in that area. So such things have to be checked before concreting. I mean, the wall gap should be properly tightened, and there will not be any gaps in shuttering. That is the second point. Then the third point is check correct spacing of steel bars in slab and beam. As we know, we are doing the reinforcement in the slab or beam according to the structural drawing that is given to us. So in it, they will specify, the structural engineer will specify how much is the correct spacing in between the bars in beams as well as in slab. The main bar and the distribution bar spacing, everything will be given. So it's the duty of a site engineer to check whether the correct spacing is given to the distribution bar as well as the main bar. Main bar, as you know, it will go first. That is, the bottom part will be the main bar, and the topmost, the second layer will be the distribution bars. So the spacing should be properly given. If the spacing is high, so some contractors may do that, because again they can reduce the amount of steel. If it is 150 mm, if they go for 200 mm, if there is no proper checking by a site engineer, they can of course they can benefit some steel bar from that particular design if there is no checking happening in that site. So other thing is that it's not about profiting some one or two, or gaining some one or two steel bar. The main problem is that why we design the steel bar, why we design the slab, to take some loads, the live load, dead load, wind load, and it is designed, and even the design, the spacing will be is designed according to the load taken by the slab in future. So if the between space between two bars is increased according to the wishes of the contractor, it will directly affect the design load. That means the slab will fail one day. Some, if the load, the predicted load can increase from the design load, and the slab will eventually fail. There will be cracks in the slab. So such things have to be checked by the site engineer before concreting. It's a must. Then Proper car block. That is, as we know, in a previous video I have detailed about the functions of a car block to give space between the reinforcement bar and the uh, downside or the upside of the slab. That means the car block prevent the reinforcement to come outside of the slab. Okay, so that it will never come into contact with the atmosphere, and it will eventually stop the corrosion or rusting of that particular steel member. So the cover block, whether the cover block is given at proper interval, that is per 1 square meter, it is supposed to, we are supposed to give 5 car blocks. Okay, like that, if it is given in the, if it is the beam, whether the car block is given the sides and top and down, that also have to be checked by the site engineer. Just like the slab also, the size of the car block also had to be checked, whether it is 25 mm, 50 mm or 60 mm for beam, that also had to be checked. And whether is there any area where there is sagging of the reinforcement happens, so that it is the distance between the reinforcement and the soffit is very less, or there will be a chance for very less concrete to be in between that distance, that also had to be checked by the site engineer. So the construction should be done in a very neat way. It is the prime duty of the site engineer or the civil engineer present at that site. So number of car blocks, and if the car blocks is positioned at the correct interval, that all things, these things should be noted down by the site engineer. If it is not done, then he have to tell the worker to do it again. If otherwise you had to rewind, unwind all the things and then again put this thing, and then all these things have to do. Along with that, the lapping length of the bars in the beam, and whether the extra bar is there, how, if the extra bar is at the correct spacing and the crank is at the correct spacing, all these things have to be checked by the site engineer. And also the distance between two layer bars, that also had to be checked, whether it is according to the designed drawing by the structural engineer or not, because it is that design is given just to follow, not just to follow, but to understand it, and there are some reasons for that particular length and interspacing of all these steel bars. So it should be done according to the design only. The site engineer is not supposed to do according to his free will or the contractor's free will. So that should be taken care of. The mastering, usually when we are doing the concreting of a slab, you know, when if it is a first floor and we have to build for the second floor also, there will be column reinforcements are there in at particular intervals where the column is supposed to come. So if we don't provide a master ring for all these columns, after the concrete set, the reinforcement bar will go like this, it will sway away, it will not be in the straight line. So for that, to keep it in the straight line and to reduce the difficulties for the further lapping of that column to the top level, we need to put master rings for all the columns. That should be one of the important points that a site engineer have to think before concreting. Regarding the shuttering of span, you know, the span which will help the shuttering on top of it. So you know, if it is a span, then the main load is happens at the middle of that span. So just check whether the middle of the span have a individual prop there, so that it will take the wall load. And also check the distance between the props, and also check the distance between the span, if it is adequate enough to hold the shuttering above. The site engineer had to check whether proper oiling had to have been done before concreting for the shuttering, and the oil should not be higher or lower. If it is high on the high side, then the steel bar may get this oil and it will affect the addition between steel bar and the concrete. So steel bar should be avoided from coming into contact with the shuttering oil. That also has to be checked. And regarding the chairs that we are giving in slab, you know, chair is a thing which is given when there are double layer of seals coming, main bar and diffusion bar, or there are two-way slabs. In such cases, there are two layers of or near the cranking area, there are two layers of steel bar coming in the slab. In that area, in order to provide sufficient space between the top layer and the down layer. We are providing enough chairs. These chairs also sometimes the inverted beams, inverted slabs for the cantilever also. Sometimes the for the cantilever balconies or cantilever area, we need to provide the chairs because there are two layers of steels coming in the slab. So in such cases, adequately and properly the chairs need to be spaced at particular interval so that the top layer will not come in contact with the down layer, so that also it ensures that enough concrete is going in between these two layers. Okay, so proper placement of chairs should be checked by the site engineer at site. Along with this, we have the site engineer have to check the crank have to be done at proper distance. If that particular distance is done, that is L by 4 if it is done. And also when he took the length of the crank area, if it is correctly done or not, that is 0.42 into D. So such things the site engineer have to check. Also the number of extra bars where it is given, if it is a cutter element bar or a crank bar, that also have to be checked, and the length of all the cutter element bar or the crank point along with the extra bar have to be checked by the site engineer. It's a must. It happens that when they put the electric conduit lines in the reinforcement, everywhere, in most of the cases I have seen that the electrician put it in very nearby, like this, it will be like this. There will not be any space in between like this. But so if you are a site engineer, then tell them I need space in between the conduits. It should not become like this. So it should be like this, so that enough concrete will go inside that conduit area in between the conduits, so that it will take some compression. If there is no concrete there, then how can the slab take compression in that particular area? That area will be weak in compression, so there will be chance of failure, development of cracks at that time. Okay, that is one point. Second one is that the site engineer have to check the development length, or the anchorage, and also the lapping zone. He have to see the lapping zone and whether lapping length is correct or not. That also he need to check by a measuring tape. When they are providing the sleeves also they have to we have to check. That means the site engineer have to check whether that sleeve have to be closed or not, whether the seal is closed or not, otherwise the concrete will go inside it. The prime thing that the site engineer or the manager have to see, the civil engineer have to see before concreting, is that whether all the reinforcement are in line and level. That's a must. And also check the intersection area where a column meets a beam area, and there check the stirrups also. Stirrups, when it comes from the column area, the least distance is 2 inch, and after that the stirrup ring distance between the stirrups can increase. That's according to the design. So that junction is subjected to lot of shear, so the distance between the stirrups should be less at that junctions. And also check whether it is the beam and the column is anchored in the correct way or not. That means check the Derman length. So these are some of the points that a site engineer have to check before concreting in a construction site. Hope you understand the points. So I will come with another video with another subject. Till then, goodbye. So if you like, please subscribe, share and like. Thank you very much.